Let's consider one more example in which there is application of Louis de Broglie's theory that even matter has wave character. The question is saying calculate the mass of a photon with wavelength 3.6 angstrom. So as just I've drawn a diagram to have a mental picture of it. Suppose this is a source of light and it's emitting light, and the wavelength of the light will be the light or the electromagnetic radiation will have both will behave both as a wave and as a particle, depending on whether it is interacting with another with a metal surface with another metal, or whether two waves are interacting with one another. So according to the phenomenon of photoelectric effect, or Max Planck's quantum theory, it says that the energy possessed by the light, when it flows in chunks of energy, the packets of energy called photons. This, like this. But this question, and for this light, since they are photon, they are traveling with the velocity of the light, that is 3 into 10 to the power 8 meter per second, and they have given the wavelength as 3.6 angstrom, 1 angstrom into 10 to the power minus 10 meter. And you are supposed to calculate the mass of this photons. What will the mass of each photon? That's what the question is. According to de Broglie equation, what is said? De Broglie is saying that even matter has dual behavior. It has some wave character too. So what will be the wavelength, or what will be this? So what will the wavelength associated with a matter which is moving with velocity will be wavelength is equal to Planck's constant by momentum. So this is de Broglie's equation, which gives the relationship between the wavelength and its momentum when the body is moving. So any body which is moving will have wave character, and its wavelength is given by this relationship. So if we want to calculate the momentum, which is mass into velocity, it will become h by wavelength. And if you don't want to know the mass, then the velocity will go this side, on the other side of the equation. So it will be like divided by the Planck's constant is 6.626 into 10 to the minus 34 joule second. Wavelength is 3.6 angstrom. Converted to meter is 10 to the power minus 10 meter. Because as I told earlier, 1 angstrom is equal to 10 to the power minus 10 meter. Into velocity, what will the velocity of the photon is the velocity of light. All the electromagnetic radiations, whether X-rays or radio waves or microwave or infrared or visible or ultraviolet rays, they all move with the velocity of light in vacuum, which is 3 into 10 to the power 8 meter per second. So simplifying, you get around 10 to the power minus 33 kg. Yes, it's a very, very, very minute number, 3 into 10 to the minus 33 kg. I hope it's clear.